This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Flow Field Modulator is excellent. And now we get on to your research question here, which is looking at kind of what do we do about this problem? How do we change these low-rise buildings with some innovative roof system geometries that help alleviate these lifts, the suction forces that you mentioned? So for the non-wind engineers in our audience, can you kind of give us an example of some of these different roof geometries? And when the project is complete, do you expect you'll have some practical suggestions for architects and builders of how to deal with these challenges?
Right. No, that's a good question. So for this particular project, we have two main goals. The first one is that large-scale turbulence generation that I mentioned earlier. The second one is looking at how we can sort of alleviate or mitigate or reduce the wind effects, specifically on the roof of low-rise buildings. Now, there's been some wind mitigation strategies for roofs that are currently existing. So, for example, parapets, when you look at parapets, so parapet is essentially a protective wall that goes along the edge of the roof of a low-rise building. So those have multiple functions, but one of them is to reduce the suction pressures that we were talking about earlier. Now you can get creative and you can optimize and enhance the geometry of, let's say, a parapet to sort of confuse the flow and simultaneously being able to reduce the pressures on the roof. Typically, the highest suction pressures occur near the edge and on the corners of the roof. So if you are able to sort of change the structure of the flow so that you can sort of redirect the flow and lessen the effect in those areas, that can go a long way.
Yeah. For really long time listeners of the show, all the way back in episode, maybe 3 or 4, we talked to Dr. Rindam Chowdhury from FIU about a system they developed there that actually captures the energy at the edge of a parapet and turns it into electricity. It was really cool.
Right.
So when you talk about some of those creative solutions, you can get real creative with that.
Right, exactly. And going back to sort of differentiating between high-rise and low-rise building, high-rise buildings, there's also been techniques in order to mitigate wind effects by enhancing the geometry. Low-rise buildings, as you mentioned, FIU has done some work to try to mitigate wind loads on low-rise structures, but there's definitely a lot of ground that could be explored in that particular research area.
Yeah, and especially doing it in a way that captures the existing, building inventory as well as new construction, and solutions are different for each one. And this gets from research into development and practice, but there's economic concerns, there's cultural concerns, there's just the hassle of putting something else on your building. It's like another thing.
No, definitely. I mean, we definitely don't want to reinvent the wheel. So if we can design or come up with some innovative design that could be implemented to existing low-rise structures, but also these would be technologies that could be incorporated potentially to future structures. So let's say we're at the end of your project and we're talking to our friends at the NSF about how amazing it went. What are some of the really great results that you're expecting to see over the next little while you're working on this with your team? Well, specifically, we want to one of our main goals is to sort of link the wind field that we're generating with the assistance of the flow field modulator to how effective these wind mitigation strategies are for the roofs. So we can develop a roadmap where we know that for certain wind conditions, and let's say if you're in a particular geographic location where the terrain is different and your wind field is going to change, and that could potentially affect the wind mitigation strategy that you would use for your roof, then we can sort of give some guidance in that regard to practitioners and engineers. And with all that information, we can basically provide recommendations. And so, for example, if for a particular low-rise structure situated in, let's say, in front of the water, so that will be more of marine exposure, so the turbulence properties are going to be different there. So then we would make a recommendation that would be different from, let's say, if you're in a more built-up suburban area. So those are sort of the things that we're looking at.
So kind of a follow-on question here that we didn't have in our original thing, but I'm thinking, so how does a practicing engineer find this research that you're doing? Like, how do you communicate these things? Is it through code changes? Is it sending out emails to lists? Like, how do you go about communicating this?
Yeah, so what we call the tech transfer, technology transfer, and giving this information to practitioners and engineers is critical for us. Typically, we as in academia, as academics, the publications, peer review publications is one way, but also there's a lot of my colleagues and wind engineers. They're very heavily involved with wind load provisions, updating wind load provision, for example, wind standards such as ASC 7. So being able to get this information and transfer it so that we can implement it, let's say, in future versions or editions of building codes is critical. Mm-hmm. That's something that would once we get the results, once we finish a project such as the one that we're working on, that would sort of be the next step so that we can see the real impact of the project.
So it's a mix of kind of short-term, publications into journals and things like that, and then more longer term, like updating a building code is sometimes a 10-year process, or up to anyway, depending on what part of the cycle you're in.
Right, and also a big part of NERI is design safe, which we might talk about it later on. Also being able to share the data and also share the data in a way that engineers and practitioners can understand. So interpretation and being able to organize and structure the data so it's easy to understand. It's also critical, and that would also be a contribution of the project.
Yeah, and Bill Holmes, if you're listening, this is where our network coordination office team is really good at this. We have a tech transfer committee. You're probably aware of that. But for those who are listening who may not be, like, this is one of the things that we do is talk to amazing people like Pedro and say, hey, what you working on? Like, how can we tell people about it? And guys like Bill Holmes and the rest of the tech transfer committee have those relationships with practicing engineers and engineering firms who would be interested in it in various regions, and know how to talk to them in ways they can understand, so that you can keep doing what you do and we can do our thing. And so you don't have to worry so much about doing all of that yourself.
Right, exactly.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.